Today we're covering material in preparation for section 5.3 as well as section 5.4 that we'll cover today in lecture. In these first examples, I actually want you to practice working with your calculator. You see, there were a lot of issues on the most recent exam 2, where people missed a lot of points just because I could tell they didn't quite plug the function correctly into their calculator. So that's what we're going to be practicing here. With this first set of skills, notice I have something like 1 over x squared minus 9, and I'm evaluating it at x equals 5. When I plug this in my calculator, we'll go right to the calculator here. I go y equals 1 divided by. Now here's the important part. X squared minus 9 has to be in parentheses. So parentheses x squared minus 9. If I didn't, and I just plopped it in like 1 divided by x squared minus 9, then what we're really doing is something like 1 divided by x squared minus 9, right? With order of operations, if you want the minus 9 to be in the denominator, you have to put parentheses around the entire denominator. See, when I go to the graph, you can see the correct graph here. And then if I go to the table, we can immediately pick up the x value at 5, 0.0625. So this is 0.0625. So it's very, very important that that is taken into consideration. Now, looking at the next one is another common mistake that I see. We have negative x squared and negative x quantity with parentheses squared. We're evaluating it at x equals 4. So in the first one, if I'm just plugging in negative x squared and I'm plugging in 4, it becomes negative 4 squared. The negative is not being squared. It's not inside the parentheses. Therefore, this comes out to negative 16. If I'm looking at negative x squared and I plug in 4, then I have negative 4 quantity squared. There you can see the negative is inside the parentheses. It is also getting squared. Therefore, we have positive 16 here. It's another super common issue I saw on the test. Lastly, we're evaluating something like x plus 6 over 3x at x equals 2. That would be 2 plus 6 over 3 times 2. Now, when you plug this in your calculator, going back to the calculator, and I need to also use parentheses. So if I want to do like 2 plus 6, and all of that needs to be in the numerator, I need to put it in parentheses, divided by. Now I have 3 times 2, also in parentheses. If I don't use parentheses, and I try to just type 2 plus 6 divided by 3 times 2, well, that's a very different answer, right? The correct answer is 1.33. The incorrect answer would be 6. And so you have to be careful that what you're typing in reflects what the question is asking. So this really should be 1.33. All right, so take some time to practice those. When you look down here at the practice problems for this section, notice I have a bunch of functions for you to practice, typing them in, and then actually going to the table and finding all your x values. And then I have a different set of practice problems that's a little different from what we've done in the past, where I give you a function and I give you an x value, and I actually give you the answer. So we say something like, Sarah evaluates 1 over 2x at x equals 4, and she gets 2. Is that correct or is it not? And if it's not correct, what mistake did she make, do you think? So that's another great one to practice. And there are several problems here like this. So the other bit of content I want to cover with you guys is fractional exponents. See, we are going to have to go back and forth with these a bunch moving forward. So you have to get used to plugging them into your calculator as well, using fractional exponents. So let's say you had something like what we have over here, the nth root of x to the m. Well, that can be written as x to the m over n, and I always think of it as power over pocket. So that way you always know how to pick up which one goes on top, which one goes on bottom. The pocket, of course, is the pocket of my root function, and the power is my exponent on the x. So if you just remember power over pocket, you'll always be able to write these out. So if we're given x to the 2/3, we want to rewrite it as something with a radical in it. So we have power over pocket. That tells me my power is 2. I'm going to have x squared then, and my pocket is 3. So I have the cube root, or the third root, of x squared. Now going in the backwards direction, I have, again, power over pocket. So this must be x to the 3rd divided by 5. Now let's do this again. Again, thinking power over pocket, I must have 8 squared. In my pocket, I have a 3, since it's power over pocket. But this is a perfect example of something you would actually want to plug this side into your calculator. On your calculator, if we go back for a moment, if I type 8 raised to the, is power over pocket, right? 2 over 3. 2 divided by 3. You can see how it wrote the 2 divided by 3 in the exponent. I didn't necessarily need to use parentheses there because I can see it is writing all of it in the exponent. If you have a TI-83 instead of a TI-84, you have to use parentheses. But if I hit enter, you see we get the number 4. And why does that make sense? Well, 8 squared is 64, and this third root of 64 is, in fact, 4. But it was much easier to actually type it into my calculator, 8 to the 2 over 3, rather than the third root of 8 squared, because we don't really have a third root function on here, on our calculator. So moving on to the next one, we have a 5 sitting out front. That 5 isn't going to change. There's no parentheses, so the 3 over 2 is not being distributed to the 5. It's just on the x. So again, we have power over pocket, which means I have a pocket of 2. We typically don't write those for a square root. But then I have x cubed. So this becomes 5 root x cubed. Now let's go the opposite direction again with this very last one. If I have a root x, there's always a hidden 2 right here and a hidden 1 in the exponent. So we know that becomes x to the power over pocket 1 over 2. Now, if I have the same idea for x cubed, I have power over pocket. My hidden pocket is a 2. If there's ever not a number written there, you know it's a 2. So power over pocket tells me x to the 3/2. Now, we can actually use our exponent rules here, where I can add my exponents since the base is the same. So that's 1/2 plus 3/2. Well, that's x to the 4/2, which of course is just x squared. So that's how that one's simplified. So sometimes working with fractional exponents is a little bit easier to actually simplify them down to what you need. So there's a ton of those practice problems here as well. So please take some time, go through these, make sure that you're clear on them. You are expected to be able to go back and forth with these types of problems. And as always, reach out if you have any questions.